Okay, so in this today's session, we are going to focus on data analytics part. Mainly, we will talk about tools and techniques we are going to use in teaching and learning the subjects. So you can see here that once we finish, we are going to work on a WEKA. So when you look at the WEKA, in WEKA, the WEKA software is written using New Zealand University WEKA 2. And these are the authors who actually led the development of the tool. So they have published a book on data mining or talks about machine learning stuff as well. Then the second book also go along with the same, but the third one is more practical one. Andrew Nagy is one of the pioneers in machine learning, which he has written a book mainly focusing on practical aspect of machine learning. So I highly recommend you to read, these references in case if you're interested in learning more. Right. But my today's session, I'm going to talk about a couple of ideas, and then I'm going to talk about those in detail, right? But before we start, we need to learn what this data analytics, data mining, machine learning, and so on. Simply, when you talk about the data analytics, given the data, we would like to interest in identifying patterns of data. But then particularly the algorithm we use, we call machine learning algorithms. So mainly we focus on all these data analytics platform. We focus on machine learning algorithms. So before we talk about what machine learning is, let's try to understand what a learning is. And we all know that traditionally the learning happens through by studying, experiencing, or even being taught. And then, or like you can become aware of the information from observation, you can commit to memory, to be informed of a certain, to receive instruction. So that's learning. But when it comes to machine learning, that means we wanted our computers to learn. And how is the question. So what we do in machine learning, we present a lot of examples. For example, if you want to separate cats from dogs, we present the computer with an example of cats and dogs. And then we say, okay, we build a model, meaning like we train the computer to distinguish between cats and dogs. So simply we can say machine learning is an area where we focus on learning from examples. Not only that, particularly machine learning focus on improving the performance of learning algorithm, but particular algorithm at hand. So if you look at like some key definitions of machine learning, Arthur Samuel in 1959 mentioned that it's a field of study that gives computers to the ability to learn without being explicitly programmed. So what it means usually when we are developing a program, we have to write the program logic. But then with machine learning, we can give that ability to learn without exactly telling what needs to be done. So that is one way to define the machine learning area. But then there are more detailed explanation given by Tom Mitchell, again, one of the pioneers in machine learning, who has written a book on machine learning, which is used everywhere. Tom says the well-posed learning problem, a computer program is said to learn from experience E with respect to some task T and some performance measure P. If its performance on T as measured by P improves with the experience E. So he has actually separate out this particular machine learning, because it says to say that computer is actually learn from experience on particular task, because there are many tasks in machine learning which we can actually train computers, starting from classification, clustering, and so on. And then when you say like how good the computer program recognize these different categories, we have to measure using some performance measure. Ideally, we can use accuracy, but then in some, depend on the application, we might have to use others as well. So put into simple words, you can say machine learning investigates how computers can learn based on the data. Right. Now, having said that, in machine learning and also in data analytics, we talk about different algorithms which identify patterns in data. So this pattern in general, we can say structural description, which means that we can use these structural predictions to predict the new outcome. Or in some cases, we can use this to explain why particular decision has arrived. So these methods coming from various other areas. There are methods originating from artificial intelligence, statistics, and research on databases. Right. Now let me talk about a very simple toy problem, which we try to understand what this business analysis and data mining is. So in this example, there are 14 instances, which means there are 14 records. And out of 14 records, you can notice that there are 5 columns starting from outlook, temperature, humidity, wind, and play. So the last one is what we are interested in, play attribute. This is particularly playing a particular game based on different weather conditions. Right, small question for you. Right. So what is the state space? Right. So that means we have some weather conditions, and this table we have a record of whether we have played or not. This is sometimes called history of data. Right. Okay. And you can see there are 14 instances, which means we have recorded how the outlook is in 14 days. And we have recorded whether we have played the game or not. Right. My question is, what are the possible combinations? That means, let's start with outlook. So if you take outlook, right? If you take outlook, you can see that, right? There are 3 different values. Yes, agree? There are 3 different values are there. We have sunny, we have overcast, we have rainy. So we have 3 different values. Look at the temperature. We have hot, mild, cool. Again, 3 different values. Humidity. We have high and normal, 2 different values. Windy, true and false. We know now each of these, we have different categories. Outlook, we have 3. Temperature, we have 3. Humidity, we have 2. Wind is 2. My question is, given these different values, my question is, what are the possible combinations? In other words, this is a sample, right? What is the population size? Whole population, my question is. Given these variations, possible values for each of these columns, my question is, what is our population? Possible combination. know all possible combination, you can multiply by 3 by 3, that is 9 by 2, 18 by 2, that is 36. So ideally, if we could collect all possible combination, that means we can have a database of 36 records. And which means we know all the combination. But reality is you can't do that. Right? You are not going to experience everything, but you have some. Right? In this particular case, we have 14 instances. Right. Now the challenge is when you have a new date, if you know what is outlook, what is temperature, what is humidity, and what is windy, how do you decide whether to play this game or not? Right? So that is what our question is. So having said that, you can see there are many solutions we can propose, or many algorithms we can use to identify the answers. I will show you some example today, and then I will elaborate more with the tool, right? First one, decision trees. Sorry, decision rules. So you can see here, the data set is on the top, and then the down you have a set of if-else statement. These are not handcrafted, which means you have not written this explicitly, but this was the outcome of an algorithm. So what really happens in here, you put the data in, right? And then machine learning models gives you back a rule set which reflects the rules about your data set. Right? Got my question? Any questions? Right. Okay, so ideally, if you put the data set and if you use the decision tree algorithm, then you will get something like this set of rules. Second one, you can represent your data as a tree structure. What do you mean by tree? This is like upside down tree where you can find from the data we have outlook attribute. I told you like we have outlook attribute. And then in outlook, we have 3 different categories. So you can see here 3 different categories. Right? And then you place other attributes while trying to create a smallest tree as possible. Right? So that's what you can do with decision trees. So the outcome is something like this. How we got it, I'm going to discuss. Next, like decision rules or classification rules, usually you have a one attribute in the right hand side, right? But there's another rule algorithm. In those, you can find any arbitrary combination, any arbitrary attribute combinations, right? So these are called association rules. You need to know like what are the association among. So this could be used, and you can see we get large number of then if then, right? Here. Next, you can see instead of saying play yes and no, you can say play how many minutes. So some days you might play 5 minutes, another day you play 20 minutes, 30 minutes, and so on. Right? So that also can example. So in this particular example, you will notice that we are predicting a numerical value. It's like, okay, instead of saying that you are going to play yes or no, you will say how many minutes you are going to play. 10 minutes, 20 minutes, and so on. So similar to that, this particular case, what we did, you have 209 configurations, which means that you have 290 data points. And then out of that, you select the important ones, and then you can write down a linear equation. So algorithm that we use is called linear regression function. Right. Now that we discuss, we can talk about where these data analytics tools are important. So you can notice that it could be applicable for many areas, starting from science, business, and web. These are only some of the examples. Applications like astronomy, bioinformatics, drug discovery. In business, we have advertising, customer modeling, e-commerce, fraud detection, and web, we have search engine. So you can see there are a lot of applications out there. Now, the next part we will see how some applications used in this area. So this first example is about processing loan applications, meaning like usually whenever you want things to be done, one way you can go and get a loan. But then we need to know like how it happens. So loan processing application, usually you have a questionnaire with financial and personal information. And then the question that the bank is trying to identify is, should money be lent, right? Why we are saying that 90% of the cases, usually we say the borderline cases, which we need to refer to officers. Right. So these are the cases. But then again, how they have implemented. So they have considered 1,000 training examples of borderline cases, 20 credits. And then if you do that, usually we get about 70% of the cases. But if you do it randomly, it will be about 50,000. Right, let's move to the next one then. This is, any guesses about these images? Can you guess what these images are? Now, these images are actually oil leakages in ocean. We'll sometimes say oil slicks. So the problem is these are like some aerial images, and when you're trying to observe from images like this, it's very hard to identify whether it's a real oil patch or not. Right? This is where the problem comes in. Right. Now, since this is very difficult, usually what happens, a professional will go through each of these images and then classify whether it is a real oil silk or not. But problem is this is expensive, right? Identifying them manually. So therefore, you need some way of automating this, which will give you better accuracy. So in machine learning approach, this is how they have handled. They have simply extract the dark regions, and then they have identified this information, and attributes are as follows. So they considered the size of the region, shape, area, intensity, sharpness, jaggedness of boundaries, proximity of other regions, information about the background, and so on. But there are some constraints in this problem because only very few examples you will see oil silks. And the data will be unbalanced. Therefore, we need to do something about this. Right. Another example would be like load forecasting. usually in electricity supply companies, they need to forecast their future demand. So how do they record? They are going to forecast of min-max load for each hour. It'll direct to significant savings. Then manually constructed load model that assumes normal climatic conditions. The problem is adjust for weather condition. And if you look at the static model, you will have base load, load periodically, and effects of holidays. So machine learning approach is simply you look at the correlation and look for more similar days. And they considered attributes such as temperature, humidity, wind, speed, cloud cover readings, plus difference between the actual load and predicted load. So you can average the difference among the three more similar days and to the model. And then linear regression sometimes conflict from other weights in the same function. Right. To discuss the last part of what you need to know when you're working in this industry, data analytics and so on, you have to think about ethical issues, which is we say that it's not good to have them. But there are already existing issues in this. And then we can use data mining, machine learning to offer use to discriminate loan applicants. For example, you can look for some particular information like sex, their religion and race, then it could be a problematic. Next, same information. Last, sometimes you will notice that the area code will be correlated. Right. Now let's look at how we can actually try some of these examples in WEKA platform. So small exercise, I want everybody to go to Google and type WEKA 3. Okay, type WEKA 3 and download you go to WEKA 3 data mining toolkit. Click on download and install. So click and download. So once you get download, you can double click and then it will automatically install the WEKA in your system. Explain the new next setup. Now that I have downloaded my file, let me share this. Right, so I'm going to double click on this one. So you will get a simple application like it. Go to next, I agree, go to next. You don't take this much for the easy one. Right. Now, in my case, I installed the WEKA. So let's go and open the WEKA interface. Right. So WEKA is, I told you, like we can use for machine learning, data mining, data analytics related tasks. So this is a graphical user interface which you can use easily. So let me show you like some of the things that you can do with WEKA. So there are some few applications comes with WEKA. So first you need to start with the Explorer. So when you click Explorer, you should be getting some interface like this. So in this one, we can use to open data set and start analysis. So for example, let's say we'll open some default data. Remember our weather data set. So I will go to C drive, programming files. Okay, WEKA, go to WEKA folder. Inside that, you can find there are some data sets available. I will double click and I will select weather nominal, which is our data set. Once you load the data, if you want to edit anything in the data, you can click on edit button. And when you click edit button, you can see the data set. As I told you earlier, we have 14 instances. Now that's the first part. But when you select attributes here, you can see some visualization information here. So for example, Outlook, you can notice here, we have two class problem, play, yes or no. In Outlook, for example, you can see that depending on their attribute values, sunny, we have 5, overcast 4, rainy 4. But we notice that overcast is always classified in one particular group. So that's what you will see here. Similar to that, next criminal temperature. humidity, windy, and then finally play. Right. I hope you get an idea like use of WEKA, for example, very easy to understand. So let's first explain how the data set can be used to for various tasks. First one, if you want to classify, the first algorithm that I am going to discuss is called 0R, which is no classifier, right? And then you can say start, which you will get some information. So of course, in this particular algorithm, 0 print is a class value as yes. So it actually simply go through each and every record and select the best one. Right. So that's what 0R. Similar to that, you can use 1R, which is when you run it, you can notice that the output is depend on the attribute values. If it is sunny, then no. Overcast, that is yes. Rainy, yes. So that is the level 1. We can say one level decision tree. But if you want to do visually, then we can go to create, let's select trees. J45 is the algorithm we use. And then I'm not going to change anything. I'm just going to run. You can notice that, okay, we get some visual representation of the tree. Let me right click it, visualize. So you can see now, you will get the structure. Okay, so these are the things that you can actually do in data analytics platform like this. So as you can see, the very first one we call pre-process tab, we can do changes to your data. And then we have tab for classifying data. Cluster, identify similar groupings in data. Associate, and then you can also have select attributes and finally visualize one. Okay, so with that said, I will finish for today. Then we will have it next week, the theory part. And then I will explain how you can actually implement using WEKA. So you can play around with WEKA so that you are comfortable WEKA interface from next class.